I had one from the web assign.
Excellent.
It was... Okay. Use Newton's method to approximate the given number to the correct 8 decimal places.
Excellent.
The fourth root of 79.
Excellent. Perfect situation. Can anyone tell us which function are we looking at?
The fourth root of x.
Of course. We are looking at the fourth root of x. So in other words, when I solve the equation x to the fourth equals 79, it's the only time in which I will apply the fourth root. There is no other way. I will not apply the fourth root on any other equation unless I have x to the fourth, blah, 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 which means that I am looking at the fourth, the function is x to the fourth minus 79 equals 0. So this is our function. This was just an explanation. Maybe I shouldn't use f. I'm going to use f1. So it's not the same. So when I solve this equation, this is the function that I'm dealing with. And yes, the solution to this will be this number. No question about it. Because when I move 79 to the other side and I take the fourth root on both sides, then I get this. So there is no discussion there. So this is our function. In order to use Newton's method, I have to create that Newton's function. So I like to call it, you can call it the way you like, but not f of x. Anything you want, but not f of x. So I call this Newton's function, which is x minus the function over its derivative. This is what I am going to plug in the graphing calculator. Newton's function will go into the calculator. And I have to start somewhere. I don't know where. Well, I know it has to be an interval that includes this number. So I know where I'm, but it has to be a 1-unit interval. So I'm going to share my screen. I'm going to go to the calculator. I am not cheating, but I want to see 79 to the power 1/4. So it's 2.9. So my interval will be between 2 and 3. Between 2 and 3. And this is not cheating. I need to find the 1-unit interval because I need to identify my x0. The book considers this the first iteration. It's up to you. I accept both. I consider this the initial value. However, you can also consider it the first iteration. But it's not calculated. It's picked. I pick the initial value. So that's why I don't really like to call it the first iteration. The book considers the first iteration. I'm okay with both. So I already know, normally I wouldn't do this. I will put the function in and plug in numbers and see where it changes from positive to negative by the IVT for continuous functions. I will say this is continuous everywhere because it's polynomial. And I will say that f of 2 and f of 3, one of them is positive, one of them is negative. I don't know which one is positive and which one is negative, but it doesn't matter. Change the sign. We can determine that. Plug in 2 in this function. So when I plug in 2, 2 to the 4th, so this will be obviously less than 0 and 81, so this will be positive. So by IVT for continuous functions that change sign on the interval 2, 3, there must exist a c in the interval 2, 3 such that f of c is 0. We know that that's the IVT. I'm quoting the IVT here. Intermediate value theorem for continuous functions that change sign on an interval 2, 3. So I have that. So now when I plug in 2, the denominator is not 0. When I plug in 3, the denominator is not 0. It doesn't matter where you start. You tell me which one you want to pick. If you pick 2, it may take 3 steps. If you pick 3, it may take 2 steps. It doesn't matter. 2 or 3 steps or 4 steps, it's okay. But I have to pick. So again, I call this the initial value because I pick it and not the first iteration, but I'm okay with both. So which one would you like to pick?
2.
2. Okay, fine. So we pick 2. So then we go back to the graphing calculator in y equals clear whatever you have, and we directly put in Newton's function. X minus, don't forget parentheses for the top, x to the 4th minus 79, close, divided by parentheses for the denominator, please, 4x cubed, and close. Not there, but here. Once you have this in the graphing calculator, go second and quit, get out of there. And now we call function y1. Variables, click on variables, move to the right, y variables, click to the right, and then y1, and then click yes, and then put in 2 because that's what we wanted to start with.
I'm sorry, can you go back what you had to click? I'm sorry.
Variables, y variables. Remember, I have that video also. I recorded this part last time if you need to review it. Y variables, and then click, and then call y1, and variables, y1, yes, and we decided to plug in 2, close, enter. This is our x sub 1. X sub 1, 3.96875. I'll stop for a moment. You can say, wait a minute. Look what I'm getting. The interval is 2, 3, and I'm getting 3.96. Don't panic. The first one, maybe even the second one, could be out of the range. But if they from here go to 16, then something is terribly wrong. Maybe we did not plug in the function correctly. But if in 1 or 2 steps it stabilizes and comes in where it should be between 2 and 3, then we are in business. So it's okay, don't panic. See, this is not even in the interval, it's closer to 4. What is going on? It's okay. As long as it's a finite number of steps that are outside and it eventually will stabilize, we normally say it converges, the method converges. But let's see step 2, 3. If step 2, 3 or iteration the second or third or fourth are still outside, something is terribly wrong. Okay, so let's go back. But for now, we are not going to panic. So here we just go to second and copy, but you're not going to press enter again. You are going to highlight 2 and go to second and answer. You want now in Newton's function, the calculator to plug in this number, the previous answer, but you don't want to type it in. You want the calculator to have as little error or give us as little error as possible. So I say to the calculator, hey, take this whole thing, whatever it is, and plug it in again. And now, it's getting close. Okay, so x sub 2 is 3.292503.415. Fine. Here you don't have to do anything. Just copy and entry. It's getting even closer. 3.0227128888. Okay, next one. Wonderful. So x sub 4 equals 2.982150521. And the next one should probably repeat a lot of these digits. We'll see. So we want, we said 8. Okay, so we still have to go. So x sub 5, 2.9813078859. I'm guessing the next one is identical, probably all of them. We'll see. Maybe I'm wrong. Good enough. No, not good enough. 2, 4, 6, 7, 8. Okay, so if that's, this will be exactly the same. So this is it. 1307501. So I'm almost certain that the next one is identical, completely identical with this one. That's it. So this is the final answer. Since they want 8 decimal digits, I will give 2, 4, 6, 8. And this is it. So as you notice, these 3 were haywire. But that's okay, because eventually the method converged to the correct answer. But now if the first one is 3.9, and the next one is 4.7, and the next one is 16, and the next one is 500, you know something is terribly wrong. Very good problem, Amanda. Thank you. Any questions on this problem, please? Good one. Good. Please don't forget to state IVT. This is a continuous function. It changes sign because it's a polynomial. It changes sign between 2 and 3. It's negative at 2 and it's positive at 3. And because it's continuous, there must be a solution guaranteed between 2 and 3, such that f of c is 0. And we found it with 8 decimal digits. Good. I'm ready for the next question. Anything else you want to work on? Anything you need help with? Anything, please. Anything. If not, we will go to the last section of chapter 4 that we need, because there is one more section, but it's connected to the next chapter. And then we'll start reviewing. So we have 4.7 to work on. Anyone needs any help with anything else? WebAssign or otherwise? Tom, do you need anything? Talia, do you need anything? Landon, you need anything? Aaron, you need anything? Amanda?
No, I'm okay.
Okay. Do we need to work on another Newton's method? Yes or no?
I'd like to do one more.
Excellent. Let's choose one with trig.
Okay. I have one here unless you want to pull one from the
No, I want yours.
Okay. It just says, so 6 decimal places this time. Sine x equals x minus 1.
Excellent. No one can solve this by hand. It's not an equation we have any algebraic methods for. So first of all, I have this. That's my first step. I have to have 0 on one side because I need to identify our function. So that's our function, sine x minus x plus 1. Immediately find f prime of x. Can anyone give us f prime of x, please?
Cosine x minus 1.
Excellent. Cosine x minus 1. And remember, the Newton's function should be this. This is Newton's function that we will put in when and if we find the interval. We haven't found the interval yet because we need to find or pick the initial value. Okay, so now I will say f of x continuous, because sine is continuous everywhere, negative x is continuous everywhere, 1 is continuous everywhere, on negative infinite to infinite. So now I have to find, hopefully, two values, 1 unit interval. So please, not from 0 to 10. That's not a 1 unit interval. So I will plug this function in the graphing calculator. Please make sure that you have the mode in radian mode. If you do not have the mode in radian mode for a trig function, you're not going to get we're not going to get what we want. So it is in radian mode. Then I go to y equals, clear everything, and punch in sine x and close, and minus x plus 1. And then I go with second and table and punch in numbers. I'm going to start from 0, and then 1, and then 2. Yay, I got it. Between 1 and 2. So at 1, the function is positive. At 2, the function is negative. That's all I need. One solution. Okay? So by intermediate value theorem for continuous functions, there exists a C in the open interval 1, 2 such that f of C is 0. Now I have to make sure that I start with the x0 such that cosine x minus 1 is not 0. But cosine is 1 only at 0. Well, I don't have 0 here. It doesn't matter where I start because cosine is 1 only at when x is 0, but I don't have x equals 0. So it doesn't matter where I start. I can start with 1 or I can start with 2 because cosine x minus 1 will not be 0 at either one. That's my first concern. So now we have to choose. Which one do we want to choose as our initial value or first iteration?